Hello, everyone. My name is Casey, and today I will be walking through the first part of my rocket section for my engineering and industrial design portfolio. So, um, we recently have started designing rockets for my second year of engineering and industrial design. So, the first step that we start with is autodesking and designing models of certain parts that we will need for our rockets, and that is what we have been working on. And then so we will design a model, we'll put it into the material we want, we'll weigh it, and then we will eventually 3D print it, and then make sure everything works and it fits well on the body. So I will be showing some parts that we've made and what I've designed. So first thing I designed were nose cones, and these go on the top of the rocket, and they help with trajectory and also creating less air resistance and drag. So these are listed in chronological order of when I made them. So the first one I made is an elliptozoid one, and I tried to make it curved and also have a uh, decent shape so that there's less drag and less air resistance. And also, you'll see down here there's a little um, trim or a cut right there, and that's so that it can fit inside of the top of the body and also be able to seamlessly connect to the rocket. The second one I made was a cone, which looks all right, but uh, in theory it might work well, but in actuality, it'd be pretty hard to 3D print this top part where it gets really thin. So if I decide to print this one out, it'll be interesting to see how it does that. Third one I made was a parabolic one, and this one I tried to go for a similar one to the elliptozoid, but add a more pointed top, which would hopefully have some differences in drag and air resistance. Next thing we made were fins, and these were pretty difficult to make because there's a lot of steps that go into it and measuring all the parts and getting it to um, the bottom of it to match the radius and the curvature of the body. So this is the first one I made, and fins help with trajectory also. But this one, it's pretty basic. I made it pretty fast just as a kind of basic setup um, for my other more advanced ones. So it's hollow, which is what um, I try to do with most of my fins because that helps it to weigh less, which will hopefully make the rocket go higher because it won't need as much fuel. So it's pretty basic, but it still is a decent first design. The second one, I made it more curved towards the bottom so it could fit onto the body well and that it glue on nice, but still the same kind of trapezoid shape. The third one I made is a tapered sweep, and this one is more of a parallelogram, I think, but it's curved to also attach to the body, but also has a more pointed tip at the bottom to help with trajectory and helping the rocket go straight. So here are all the three parts of each that I made all compared together. And yeah, so now the weights of the nodes, cones, they were all similar and only with slight differences. So they were all about 3 grams. The fins, the first one, which was very hollow, the red one, as you can see here, was only 1 gram. The second one was 6 grams. And I noticed it weighed more, so I tried to hollow out the third one, and that did help. And the third one is only 4 grams. So after that, I decided to take my favorite models and put them in an assembly. And this is what we have so far. We have the elliptozoid nose cone and the tapered sweep for the fins. And so far, I think it looks nice. And our next step is to 3D print it and hopefully assemble it and then finally launch it. Thank you for watching.